My name is Peter McGrath. I'm the coordinator of the IAP Secretariat here in Trieste in Italy. And I give a shout out to my colleague Rania Costi, who is my equivalent in the Washington, D.C. office, who's also with us here today. The InterAcademy Partnership, IAP, is a global network of academies of science, medicine, and engineering. We have 149 members from around the globe. We were founded originally in 1993. Since 2003, the General Assembly of IAP, when it came together, decided that science education should be a priority area for the organization. So we've had a global council and a science education program that's guided by the global council since those days, 2003. And there's been a strong focus on promoting through the academies, going through the academies to national education systems, the concept of inquiry-based science education. That is, in other words, some people will translate that as sort of learning by doing. And we believe that this inquiry-based education is the best way for building teamwork skills and also critical thinking skills. And if we link critical thinking with trust in science, I think that's part of our mission today. In this respect, I want to tie in today's webinar with the recent statement from the UN Secretary General's Scientific Advisory Board. Now, the UN Secretary General established this advisory board about 2 years ago, and he invited a number of global scientific networks to contribute to the discussions and the deliberations of the board. And I'm pleased to inform you that IAP was one of those organizations. The Trust in Science statement has been published by this advisory board back in September last year, so just 5 or 6 months ago. And I just want to read a couple of excerpts from it. The first one: we believe that the United Nations, under the International Decade of Sciences for Sustainable Development, which is running from 2024 to 2033, and working with diverse and multidisciplinary scientific experts from across the globe, such as everybody here, can play a role in restoring trust in science in several ways. And one of those that it highlights is promoting science education and the importance of evidence-based thinking. And in fact, it gives a special encouragement to promote science literacy programs in schools and workplaces, emphasizing critical thinking, the scientific method, and the importance of evidence-based decision-making. So you can see, I think that links in very well with the theme of our webinar today. And at this point, I'd like to introduce our moderator, Carol O'Donnell, of the Smithsonian Science Education Center. Carol is the Douglas M. Lapp and Ann B. Kaiser Director of the SSEC, which is dedicated to transforming education through science in collaboration with communities across the globe. Carol carries out work in a number of areas, but has been part of the IAP Global Council for the Science Education Programme since, I think, 2016, when we first met, actually in Chile. It'll be of interest to one of our speakers, Miguel Allende. And from that point on, IAP and the SSEC have worked together on a series of curricular teaching resources called Science for Global Goals. It's important to note also that Carol came to us through a nomination appointment by the US National Academies of Science, Engineering, and Medicine. So Carol, I hand the floor to you and I sign off here. Thank you.
Yeah, I just wanted to say good morning, good day, good evening to all of you. I'm so appreciative of the relationship that I have with the US National Academies of Sciences, Engineering, and Medicine, who jointly founded our center in 1985. We'll celebrate our 40th anniversary this year. And I'm also very appreciative of the relationship that I have with the InterAcademy Partnership, Science Education Global Council. I want to say a special thank you to Data Lee, who is in our audience today. We were introduced to each other back in 2016 when he chaired the Global Council. Today I'll moderate the session, but I just want to welcome and introduce everyone to Dr. Bruce Alberts, who will be our first speaker today. And then we'll have a panel of 3 prestigious speakers who will talk about science education, STEM literacy, and trust in science. And I'll introduce them before their panel discussion. But first, I want to turn it over to Dr. Bruce Alberts, who probably everyone here knows. Bruce was overseeing the U.S. National Academy of Sciences when I was a curriculum developer in the 1990s here at our center. Dr. Bruce Alberts, as we all know, is a prominent biochemist, the former president of the U.S. National Academy of Sciences, and has one of the strongest commitments to science education of anyone that I know. He was the editor-in-chief of Science, and much of what he'll talk about today comes from his illustrious career as a scholar. We've learned from Bruce not only from his science and scientific endeavors, but his commitment to science education. So Bruce will share with us the role of science education in strengthening public trust in science. So Bruce, I'll turn it over to you, and thank you so much for getting up at 4 in the morning to join us.
Thank you, Carol. It's a pleasure to see so many friends from all around the world. This is a great event. I hope I can be a little coherent this morning because it's very, very early. I would like to start by getting my slides up.
And as Dr. Alberts does that, please, if you do have a question, just a reminder, as Moses mentioned, don't hesitate to put it in the chat. We'll be taking questions and answers, as Moses mentioned, at the very end, but possibly may be able to take 1 to 2 after Dr. Alberts finishes.
Can everybody see my slides? Good, good. So I just want to, oops, I got see how I can make this. I just want to just give a brief bottom line here. You know, all my time I spent on Washington, D.C. in various jobs, I realized that science is even much more important for the world than I had thought as a scientist. I mean, scientists, science teachers need to achieve a much higher degree of influence through both our own nations and the world. And second of all, I learned that we must redefine what is meant by science education if we're going to really produce what Prime Minister Nehru in India first termed a scientific temper for everybody across the globe. So the important values of science we all know, critical for every society. I like to talk about honesty, generosity, and of course a strong demand for evidence with openness to all ideas and opinions, irrespective of their source. All societies need this desperately. To create a new scientific temper for the world, that will need a new type of science education for all. And boy, many of us who've been scientists were startled during the pandemic and discouraged to see how much irrational thinking and how much distrust of science exists in our countries, especially I'm from the United States. It's really a shock to us all. There's a widespread bit of everybody thinks it's fine to think without any evidence. Obviously it goes far beyond science, and it's a danger to democracy. And to me, it represents a massive challenge for science education. My conclusion is that science education is a critical tool for all of humanity if we're going to survive in the coming years. So here's my typical way I introduce science education, not as something to memorize words and facts. This is something that 5-year-olds do in the United States. In some places, you could come in from put on clean white socks during the right time of the year and walk around the schoolyard when seeds are on the ground. You come back up and take off your socks, and every little 5-year-old has the tweezers, takes off the black specks on their socks and put them in a different numbered square, and then start by looking at each speck with a little plastic microscope and drawing what each little speck looks like. And then the class has a debate and tries to figure out which of these specks are dirt and which are seeds. And eventually some kids will say, well, I think the round ones, the regularly shaped ones are seeds. And the teacher doesn't ever say, yes, that's the right answer, but then encourages the class to say, well, we could test that idea and see, and eventually the kids then decide on their own, they'll plant all the round ones in one pot and all the other specks in another pot and see if their hypothesis is correct. This is just an illustration that even 5-year-olds could do what we call science. So to remove a major barrier to progress, science education at all levels must change, including college. And here's an image of Biology 1 class at the University of Minnesota, very much active learning. I was on the Eden Prize jury, and I learned about this wonderful piece of scholarship by Mickey Chi, who tore apart, analyzed, and not all active learning is good. It's got to be a certain kind of active learning, and not this. So she did a beautiful job of categorizing, from research what actually works. And her conclusion, and you can go to the Eden Prize website and see her discussions and learn a lot more about this, is that teachers should challenge students to make inferences, that students need to produce outputs that contain ideas that go beyond the information that is provided to them. That's what a real education is. The very passive form of learning that many of us have in schools, where the teacher tells you some fact, like the endoplasmic reticulum is this, and you spit it back on an exam, you have done nothing. Your mind has done nothing. It does not work. You won't remember it. It's not really part of education, in my view. At any rate, that is a really critical thing to think about. So there are many different kinds of education, different goals for science education. For years, the only goal was the standard one, to provide all adults with a general sense of what science has discovered around the world. All life is made of cells. That's my field. That's one. You like people to know that. But there are way too many facts, and now science education just swamped and being smothered by facts. The second goal for science education, which we all support through the IAP, is to provide all adults with an ability to investigate scientific problems as scientists do, using logic, experiment, and evidence. And this, of course, is the focus of inquiry-based science education, the kind of thing that those 5-year-olds were doing with seeds on white socks. And this has been promoted by the IAP for many, many years. But there's a new ambitious goal for science education, really strengthened by what we saw today in our population, refusing vaccination and so on, is to provide all adults with an understanding of how the scientific enterprise works and why they should therefore trust the consensus judgments of science on issues like smoking, vaccination, and climate change. I think we all realize we need a much stronger focus on this goal, and we have to figure out how best to do this and how to get teaching to focus on this critical issue. So during the pandemic, the Gordon and Betty Moore Foundation, inspired by these problems, launched a study all done by Zoom that was led by Jonathan Osborne. And the summary of those results were published in Science Magazine and elsewhere. This article from Science is called Science Misinformation and the Role of Education. And stresses how we must now, everybody in society, become competent outsiders who can evaluate the credibility of science-based arguments. My current passion is this, trying to help with this effort. How can we teach students and then produce adults who recognize that scientific judgments are not merely what scientists happen to believe? This is sort of the general problem in our societies. Correcting such a misunderstandings would require that science education focus on teaching how reliable knowledge is actually produced through the remarkable community-based human invention that we call science. And so we've been, my and two colleagues down here, Karen Hopkins and Keith Roberts, have been working to create a new website that helps and encourages the explicit teaching of how the science community creates reliable knowledge. We produced a 6,000 word essay, which is up on that site now in 4 different languages. I'd like to encourage anybody who wants to translate it into their language, we'll put it up on our site again, and hopefully IAP can do this as well. It also contains a curated set of free teaching tools that collected from many other people, the best we could find by going all around on past efforts. And here's the website homepage and the website address. It's called Why Trust Science? Empowering Humanity with Reliable Knowledge. And at the top it has these tabs, the essay in different languages, teaching tools, assessments, and so on. I just want to give you some example of what's up there. Here's some of the teaching tools. Each one is on this bullet point link. This is a link to a page which then introduces a resource, a free resource that we think is broadly valuable for teachers. And the website is designed to be very quickly scanned so you could find what you want and not waste time. So here's, for example, you click on Teaching Scientific Thinking, you find this bits of free curriculum from the Science Education Research Partnership in Washington, D.C., and easy access to all these very useful types of curricula. Here's another one based on there's a sort of a amazing high school teacher in the United States who's no longer alive, but he produced these wonderful examples of how to teach the nature of science, and even his whole little book is up on this web. This is about teaching the difference between those questions that can and cannot be addressed by science. And anyway, this is 2 examples, and here's some the assessments that we've been collecting. We're still looking for good assessments. If anybody has some to contribute, we're about to post some more. But these are the little tests like which of the following is a valid scientific argument. This is a multiple choice. These are multiple choice questions. There are also other kinds of questions. But of course, teacher needs assessments to use with their students if they're going to be able to teach what we have taught. We have to know what the students are thinking, so you could improve their thinking and their understanding. So I just want to end with this stretch goal for the scientific enterprise, which we all could do together, Can our scientific societies work together to establish a system that will make it easy for every classroom in the world to interact virtually, at least, if not in person, with a scientist or with an advanced science student once per year, starting at age 5? I just want to highlight science education partnerships. Scientists and engineers are urgently needed to support teachers, and we all have a great deal to learn from interacting with these teachers who are actually in touch with children to help us do our jobs better. This is science education partnership that's existed at my university, UCSF, for 38 years. Scientists, volunteers go into all these different schools. This is a picture of San Francisco with these little red dots. And every year, these volunteers go on and interact with teachers, and both the volunteers and the teachers benefit a great deal from these efforts. And as you'll hear or have heard from Carol O'Donnell in the past about her wonderful program that was announced earlier. I'll end there. Let me skip to my favorite quote. The Society of Scientists is simple because it has a directing purpose to explore the truth. Nevertheless, it has to solve the problem of every society, which is defined as a compromise between the individual and the group. It must encourage the single scientist to be independent and the body of scientists to be tolerant. It ends with, scientists have humanized our values. Men and women have asked for freedom, justice, and respect, precisely as the scientific spirit has spread among them. Thank you.
Thank you so much, Bruce. There have been quite a few questions in the chat. We wonder, Bruce, if we could take one or two of those right now and then try to address some of the others after the panel speaks. Would that work for you?
Fine for me. Yes, sure.
Okay. So we have a question here that's from Asma Ali, who asks, if we do not allow right or wrong answers in education, how can we build a common understanding of a theory or a concept?
It was fine to have right or wrong answers. Certain things are definitely right, and other things are definitely wrong. But it's not enough just to. I mean, the common thing we do in science classes still, after all these years of trying to get science education to change, it's so much easier for a teacher to have the class, spit back bits of information that the teacher has told them. For example, the Earth goes around the sun. So that's a very important thing. But if you don't struggle with that idea, it doesn't mean it. Just spitting back that fact, that's the correct answer, doesn't really help your mind develop in a ways that will help you be an adult. The whole point of this active learning is to make you struggle and develop your own ideas. I'm just talking about myself. The things I can remember from my education when I was very young are all the projects I had where I had to figure something out. I remember very little about, the things I had to memorize. I think we all have that same experience. And that's what Mickey Chi's research has shown, really, by that children really become educated as they have to use their minds to try to develop something and think. You don't become educated by memorizing a fact and then putting it back on an exam, and whether it's right or wrong. That is not really what I would call an education. It's not what Mickey Chi thinks is being educated. And we need adults who could think for themselves. The problem in the United States, and I'm sure in many other countries, that so many people just listen to propaganda and they accept it. And right now we're in big trouble because, we got measles spreading out throughout Texas, and people believe the vaccinations are dangerous and that vitamin A will cure measles or protect you from measles. These crazy ideas, which we might call magical thinking, Carl Sagan's magical thinking. These are incredibly dangerous to all our societies. So we need science education to prepare students so when they're adults, they won't be susceptible to these crazy ideas that they see in on social media and everywhere else. Everybody's trying to fool them. I used to talk about people trying to fool them to get their money, which they do, of course, but now even more important, people trying to fool them to get their votes and vote for people who are going to be dictators or, you know, take everything from them and ruin their lives, but they don't think well enough to think, you know, they don't haven't not prepared well enough to make the judgments that they should about who's going to be our leaders.
So Bruce, given your response, we're going to ask you just for a 30-second response on this one because we think we may know the answer, but we're not certain. So given that this is a question from one of our colleagues here, many of us have been trying to spread scientific temper, as you referred to it, among people, yet we see, as you just noted, pseudoscience, non-science, misinformation spreading like wildfire. Can we even, in this, just a 30-second response, can we even begin to achieve the dream of building a community with scientific temper?
Can we what?
Can we achieve this dream of building a community with scientific temper?
Well, it's going to take a lot of effort on all our parts. You know, actually, there's been research that's shown that teaching students to understand how science works is much more difficult than teaching them scientific facts. So that's why we have to start at a young age. The curriculum that on our website, for example, it starts with 5-year-olds. You can't just have them memorize how science works. They have to experience, and it takes, there's actually been research that is, you know, obviously you'd expect. It's much harder to get children to understand how science works and why they should trust science than to memorize that you know, the earth goes around the sun. But it's much more important. And so we have to do it.
Agree. And appreciate the fact that that needs to start at a very young age and not push science education aside, which unfortunately happens in many of our primary schools. All right, so with this, and we'll be able to take additional questions and answers towards the end, but I also now want to turn it over to our panel. I'm excited about the fact that we have 3 distinguished guests who will speak with us today on science education, STEM literacy, and trust in science. The first is Dr. Miguel Allende. I've known your father for a very long time. I had the fortune of being able to meet with you in Italy this past fall. Dr. Allende is the director for the Center for Genome Regulation and professor of biology at the University of Chile. And he will talk with us about the innovative approaches to science education and his portable labs, zebrafish, and genomics in the classroom. When Professor Allende has finished speaking, we'll take 1 or 2 questions. So please, again, put them in the chat and we'll take any we can't address now at the very end. And then I'll introduce the other 2 panelists before they speak. Miguel?
Gil, you are muted. Please unmute yourself.
Okay, I think you can hear me now.
Yes, and we can also see your slides.
Okay, wonderful. Thank you, Carol, for the introduction, and also to Peter for preparing and organizing this very exciting meeting with people from all around the world, I see. So it's a pleasure to talk to you today about some of the approaches and programs we have here in Chile. I'm glad that my fellow panelists are from 2 different continents, so the Americas, Asia, and Africa are represented here. So I will talk very quickly about our programs because I want to leave time at the end for some discussion and some ideas that follow up on what Bruce has just presented. So let me move this along. Oops, here we go. So we have basically three different programs at the University of Chile where I work, funded by different organizations. We have a foundation which has funding from the Ministry of Education. And at my center, we have funding from the Ministry of Science. I will not be talking today about our inquiry-based science education program, which is aimed at primary education teachers, because I'm not directly involved with that, but rather I will focus on the two programs we have for high school education. These programs for high school education are basically three different areas. One is the portable laboratory program, which is the longest running of these. The second is high school independent projects. And then lastly, I will talk about the genome sequencing in schools, which we have started a few years back. So these programs all have engagement basically with teachers and also directly with students in the classroom. And they were started in 2013 by Jorge Allende, who Carol mentioned, and have been continuing up to this point with a pause for the pandemic. Basically, the Portable Labs program, which is the most longest running one, involves modules or topics or areas where you generate workshops between educators, that is teachers, and academics at universities, where we can combine the ideas that the scientists have on how to approach inquiry-based science and the educators input what they need for their curriculum and for motivating their students. So we have yearly calls for applications for the teachers to join these workshops, and we design the programs, and then we implement them with the teachers once a year for every one of the different modules. These teachers are then selected. We usually have about 30 per module. They take their training at the university where they use the equipment and the facilities that we have. And once they finish this training session, they can actually request the equipment to be taken to the schools so they can, in turn, show it to the students and have a 1 week long experimental session in the different topics that we have. When we take these equipments and materials to the different schools, the teachers are accompanied by 2 instructors that come from the university, and usually we recruit PhD students to do this. And this is a very good way to engage doctoral students in science education, and it's also a very good way to interact between young people with the school students, because school students are much more eager to talk to people their own age or similar ages than to some academic from a university. So we think PhD students are a key to be able to reach the students. And of course, we have evaluation systems in place to look at the outcomes, both in the short and long term. Some of the milestones started in 2013. We started with molecular biology. Then we increased it to 4 different portable lab systems, and each one of these is running independently. We had a pause, but we reinitiated back in 2023. And this program, importantly, maybe this last point I'd like to highlight, since this is a very international audience, we were able to show that this program works and implement it in different countries in Latin America. We had some funding for that by Relab and other programs that were able to spread this kind of program to other places. And the rationale behind this in Latin America, at least, is that the public school system has no funds or no way to implement science teaching with, at least with some of the equipment that is necessary for this. So it was very important to be able to support these initiatives and these teachers who want to teach things and don't have the means with the university equipment and materials. So this is basically the idea behind this. So it's not just going to the schools and giving lectures, but it's also actually taking the equipment to the schools and doing the experiments with the students. And in biology, many times you have a lot of experiments that require equipment and things that are not accessible to many public school systems. I mentioned zebrafish in my title, and it's just because I work on this model organism, sorry. This is the zebrafish embryo, and it's large enough that you can look at it on a very simple dissecting scope. This is probably not the cheapest kind of microscope you can use. As Bruce mentioned, you have some things that cost a few dollars, and you can watch these embryos develop in real time, basically. This is, of course, accelerated a bit, but during the first day of development, and I'll speed this up, you'll see that the fish is already formed. This is 48 hours, so that's 2 days. And basically, this is an excellent tool for teaching different biological concepts, such as development, of course, cell biology, physiology, and so on. And you even have transgenic lines. You can set up a very simple and cheap fluorescence imaging system where you can look at blood circulation, for example, and I'll accelerate this. If you have a transgenic line, you can switch off the lights and look at this fluorescent imaging where you can see blood vessels in one color and the blood in a different color. And here's the heart, for example, beating, and this is extremely exciting for students, and it makes them ask all kinds of questions, which are, of course, very interesting to us. And the other thing nice about zebrafish is that you can do different experiments, and here's some image of what we do with the teachers. We show them you can do a very simple experiment with cigarette smoke. Bruce mentioned smoking as one of the things that we should focus on. Here we pass cigarette smoke through liquid, and this water is incubated with the developing zebrafish, and then we look at developmental defects that are caused by the cigarette smoke. And this has been taken by the teachers to the schools, and then the students come up with their own independent projects, which is the second thing we've been supporting. And basically, they can use all the materials we have shown them, and during one semester, they can generate a project and come up with results, which they can then present in a scientific meeting. And sorry, this is in Spanish, but it's just to show you that with zebrafish, at least, we're able to generate a number of projects where the students were testing different components, both environmental and pharmaceutical or food-based, on the development of zebrafish. So this is a very nice type of experiment where they can actually test ideas that are new and that are original that they came up with. And finally, I'll talk about the genome sequencing project, which arose from something we're doing at our institute, which is called the Chilean 1000 Genomes. We're sequencing all kinds of organisms in our country. We're actually engaging citizens with this by asking them to choose the organisms we're actually sequencing. And we have a very nice educational program where we take our portable lab, which has one of these Oxford nanopore sequencers, which are small enough to be able to take to anywhere we want. And we've taken them to schools all over Chile, and they've done actual sequencing of organisms in their classroom. So this program has different steps, but basically we choose an invertebrate organism, which is easy for them to collect and find. We have some issues with animals, so we can't use those in school. So we actually do the sacrifice of the animals in the lab, but then we extract the DNA and they do the whole sequencing steps themselves. In the end, we have this conference where all the schools are connected online and they share their results, how they did with the sequencing, what kind of data they obtained. And then in one case, at least, which was published last year, we were able to actually sequence an organism that hadn't been sequenced before, which is a earwig, and publish it in a journal. And we have among the authors, which are, of course, all the scientists that were involved, we also have the School Earwig Genome Consortium, which at the end is listed, and all of the students, the school students that participated are authors through that on this paper. So we think this is also a very nice way to engage the schools and the teachers with this kind of work. So basically, these are the conclusions of our work with education. But basically, biology is a very amenable field in which you can engage students. They love working with living systems, so that's why the zebrafish we think is great. But when they choose the projects, they're very concerned about the environment, and that most of the projects that they come up with on their own have to do with that or with human health as well. And it's very important for us to support the infrastructure that the schools lack with what we have at the universities, and this is important in countries where schools don't have a very good funding. And we have reached a large number of teachers, but they always say that it would be great if this was part of some kind of teacher training program, because they feel they're part of an elite that gets to have these advantages, but not everybody can. So this is something that we have to work on and how to make it more massive. Finally, and I want to touch more on the topic of this workshop or this webinar, and these are some things that might resonate with what you just heard from Bruce. But basically, the world is undergoing not only political, economic, and social transformations, and I feel this is a crisis, but we also have climate change and other physical changes that are also affecting us. And I think this generates a crisis and an emergency. And I think Bruce is right in saying that this has to be acted upon right away. And of course, he already mentioned many of the problems that we have, which I add here. But I think, as he does, I think basically what we have, and we have to add to our education programs, is to address the lack of critical thinking skills, to understand what good and bad reference sources are, and to be always skeptical on what is declared as established fact. So while teaching scientific skills is important, and that's part of the things that we're doing as scientists, I think, just as Bruce, and I came up with this as independently, I think that the issue of scientific literacy or competency or temper, as it has been mentioned, has to be incorporated into all of the scientific education initiatives that we are working on. And I think the important thing is to teach the scientific method, how to look at references, how to know how to look for information and fact check, and also learn that even if you do this, knowledge is attained little by little. So truth is not an absolute many times. And often we work by trial and error. We're not always right, but we have ways in which to be very sure that we're right rather than just guessing. So these are some of the ideas I think we should discuss in this webinar. And thank you.
Thank you so much. Really appreciate it, Miguel. There was an interesting question here. Let's see if I can find it. So this is from Zach Pruitt, and this will be the only question that we'll take for this session, for this particular session. Says these are really cool programs, and a lot of these seem to assume that increased education necessarily implies increased trust. So Zach would be interested in hearing more on the robustness of the connection, that particular connection. He said, after the programs, what evidence do we have in terms of evaluation surveys from these programs that look into this particular connection? I think the connection is between the robustness of the program and increased trust.
Okay, I'm not sure I understand fully what the question wants me to say, but basically I would say that in general, at least in the societies or the areas where I've been in contact with, in general, there is a consensus that scientists are trustworthy. I think that's not the question. The question is, who else is trustworthy and how do we distinguish between a trustworthy person and someone that's not? So the title of scientist gives us still a certain level of prestige among many sectors of society. And I think aside from going into a political career, I think that the only tools we have are basically to go for the younger generations and try to convince them that not only scientists are trustworthy, but they themselves can generate evidence and find out about what evidence is trustworthy by becoming scientists in their own way. So I think this is the task that we have. Unfortunately, this is, of course, limited by how far we can reach. I mean, we know that a certain not insignificant number of people believe the Earth is flat. And this is, of course, as Bruce said, a big failure of us scientists. But at the same time, I think that we have no other recourse than to try and reach the younger generation to at least shift the balance into a society that's more trustworthy of science.
Absolutely. Thank you so much, Miguel. I appreciate it.
Thanks.
So our next speaker is Dr. Sharif Mayuna, and she is the former permanent delegate of Malaysia to UNESCO, who's going to talk with us about enhancing science education through interdisciplinary approaches, the case of the One Belt, One Road fusion of civilizations education curriculum. And as with the other speakers, we'll take questions at the end, 1 or 2 questions at the end. So please do put your questions in the chat if you have them. Sharifa?
Thank you, Carol, and thank you, IAP, for inviting me to speak at this seminar. I will would like to share screen in my presentation.
As you're doing that, I appreciate the comment from Dorothy, who says, I think it's important to emphasize that science is all around us. It isn't just something that's done in a lab, it's part of our everyday life. And for many of our students, doing science in their community is a part of building a trust in science. All right, turn it over to you.
Yeah, I'm going to talk about the interdisciplinary approach to teaching science and using the One Belt, One Road, a fusion of civilization education as an example. As a background, this was a project under the InterAcademy Partnership Science Education Programme. And the idea was to promote the integration of education, science and technology, culture and civilizations along the land and maritime sea routes, and also to highlight the discoveries along during this time. And also during this, the voyages of people, you have the many discoveries, innovations in terms of language, culture, religious and ethical values. The curriculum is in the form of a module, and the team that prepared the module were from Malaysia, China, Indonesia, Pakistan, and Thailand. For some of us, just to show you our land and maritime Silk Route, if you see here is it's an ancient network of trade routes that connect East and West Asia and Southeast Asia to China, Central Asia, China, and also from Europe. And you can see here that it covers quite a number of countries. So due to this Silk Route, there is an important link between ancient civilizations of like China, India, Egypt, ancient Greece, and Rome. And there's a lot of trade going on in Silk, plus also other foodstuff and spices. And during this, there is a good interchange of among civilizations, the arts, languages, religious sciences, technologies, and ethical values. The module essentially focuses on the travels of Ibn Battuta, who was an explorer from Morocco, who visited many regions and recorded his observations. And also the voyages of Admiral Zhang, who was a Chinese Muslim who came from China and visited the Southeast Asian countries, including Africa and as well as Europe. And these two civilization discoverers made a lot of observations. So the curriculum highlights discoveries and contributions of culture, trade, science and technology from various civilizations and their impacts on other civilizations through the land and oceanic Silk routes. The idea is that children can appreciate the contribution of various civilizations to modern science. And this hopefully can promote tolerance, understanding, and respect for each other's culture and tradition. And in this module, there is an integration of education, science, technology, culture, and civilizations. And hopefully that children will get better understanding of benefits from innovations from various civilizations along the Silk routes. And what essentially the interdisciplinary approach here is the integration of science and history in the teaching of science. And this is essentially for upper primary and lower secondary schools. And the basic approach in the delivery of the curriculum is inquiry-based science education. So where you have all the skills, investigation, discovering, seeking solution, development of critical thinking and creativity. And at the end of the module, you have an assessment to see to what extent children have understood or achieved the objectives of the curriculum. These are some of the activities that one can get from the book. That's the junks, and both from the land and maritime Silk Route. So these are the maritime Silk Route, and the rest, the land Silk Route. And the module contains activities that teachers can use right away in the classroom. It's all with structures, plus also the historical background of this discovery and further reading materials for the teachers. So following the completion of the modules, Malaysia had training workshops for teachers. So in 2021, we had tried to establish pilot schools where 20 teachers from these schools were given training. Then COVID started, So that was the next training program could only be held in 2023, where we had 27 participants, teachers and teacher trainers. And then in 2024 and 2025, we have another 40 teachers last year and 40 students. And this year we had another 40 students exposed to some of the activities of the contents of the module. And these are some of the activities that we carried out with teachers. And yeah, these are also some examples that we get from that teachers. Then in the student workshop, this is actually an example of a junk, how to make the junk balance or go faster. So what variable do you change so that, and what difference does it make to the stability of the junk? And this actually, the curriculum team, you can see, Carol, you're there. Datuk Lee was instrumental in getting this project approved by the IAP STP Global Council, and there's Professor Manzu, and the front here are members of the team. So, and ISTIC, which is the International Science Technology Center for South Cooperation, which actually it played a major role in executing, in completing the project and having it published. And also I would like to acknowledge the role of China in making the pilot project, experimenting the activities, and in also publicating the first draft and untested material for other countries to use. Towards the end of the workshop, we also asked a feedback from teachers. Of course, the teachers found the IBSE method a very effective and engaging method, but there were others who have not tried the interdisciplinary approach. So bringing history in the classroom was something that made the lesson more interactive, more interesting. So as you can see some of the comments that they have given here, like I learned a lot of scientific skills and knowledge about the history of Silk routes. It is a thematic lesson, and I gain more knowledge from the expertise, science concepts, problem solving, and project-based learning. And then, of course, on IBSE, major understanding about the process and structure of IBSE. Teacher can integrate few subjects in one project and be more creative and creative teaching and learning. So the overall, when we had our training with the teachers, I mean, the feedback was very encouraging, and they would like to have more. And this our project with the students too were very interactive, and they were very excited and very involved in the activities that we had. So that ends my presentation, and I'm willing to take questions.
Excellent. Thank you so much. We have, it looks like 2 or 3 questions. Let's start with the first one, which is from Teresa, who says, given your focus on interdisciplinary approaches to teaching scientific inquiry, the question is, history repeats itself. Do you believe that we should teach STEM, so science, technology, engineering, and math, with history as science, with history, because science is influenced often by politics?
Actually, my response to that is the historical context of the Belt and Road Initiative. Actually, it brings into focus the various civilizations that we need to know the contribution of these civilizations to modern science. So that's my response.
So this is a similar question, which is that logic is important in teaching science. Is it possible to introduce elements of logic in teaching science?
Well, I think there's a lot of the activities involves a lot of logic. I mean, there's a lot of reasoning when you teach science. For example, in the activities of the junk, you change a variable, what happens to the stability of the junk? There's a lot of logic in there. And you begin to reason, if you change another one, what happens? So along with this changing of variables, pupils will be able to grasp the logical component of science in these experiments.
This question is broader, so maybe we could take this question at the very end, but it's a great question about the role of science centers and science museums and the role that they play in building the public's understanding of science. So perhaps we could take that at the end, or if Sharifa, if you want to answer that question now, it's up to you.
Okay.
All right, and then our last panelist is Professor Tekatel Johannes Anshibo, who's the Executive Director of the Ethiopian Academy of Sciences, who's going to talk about science centers and STEM education at the Ethiopian Academy of Sciences. So actually, Professor Tekatel, you may be the first one to answer that question about the role of science centers and museums. So I'll turn it over to you.
Thank you very much, Carol, and thank you also, IAP. I think my presentation somehow will answer the question that was raised by Muhammad Hassan. So my talk is more specific, and it deals with Science Center and STEM at the Ethiopian Academy of Sciences. I have two slides about the academy. So this is where we are located. This building is a heritage center. It was a building that was owned by one of the foreign minister of Ethiopia 85, 90 years ago. And now the academy is housed in this building. And the academy was established, it was launched in 2010, but recognized by the Act of Parliament in 2013. And currently we have 310 fellows, and our academy has 6 working groups: agriculture, engineering and technology, fine arts, health, natural science, social science, and humanities. Out of the 310 fellows, 222 are regular fellows, while 88 are associate fellows. So at the academy, at the headquarters, we do have different centers. These are not the only activities that we do. We work on evidence-based policy advice, we work on consensus studies, and we do also popularize science, technology, innovation, and we have also panel discussion and public lectures. But at the headquarters, we have centers like Creative Arts Center, and we do have also a library, and we have an Ethiopian Academic Press, and we have also Science Center, where we have STEM, Children's Center, and science exhibits. And that part is the one that I want to present today at this Zoom. So our Science Center at the Academy have 2 units. One is the Interactive Science Museum and the STEM unit. The Interactive Science Museum have 6 sessions. The first one is, is a unit where we have exhibits or collection of Ethiopian geography, geology, and paleoanthropology. And we do have also a mini aquarium. And we have also industry and engineering unit. And we have also a natural science unit. And we also have a children's science center. These are also under development. We don't have everything set currently, but it is work in progress. At the Ethiopian Geology, Geography, and Paleoanthropology unit, our plan is to have exhibits such as earth process and landforms, and 3D maps of Ethiopian landforms. And we want to have also representative rock samples. And we also have a replica of Lucy and RD, which we already have it. That represents the human evolution in Ethiopia. So this is the one of the units that is under development. We have already collecting rocks, and we already have, as I said, replica of Lucy and RD. These are the 2 replicas that we have. This is Lucy. Then we have a small aquarium populated with very little amount of fish. And again, the reason why we have this is to motivate, students, high school students in particular, who are around this catchment area, which might not have such opportunity to see how aquarium looks like. Then we have industry and engineering unit, and the expectation is to have in this unit, items such as engines, manufacturing processes, information technology, and aviation industry. Currently, we have only 2 of this, which is a Renaissance dam model and a model for cement industry. In addition to these exhibits, we do have also another unit, which is a natural science exhibit, where we have a biomechanical exhibits, where we have items that are already in place, where biology and mechanics are brought together to show students who mainly from high school and pre-university and undergraduate students. The other unit that we have is a physics exhibit. In the physics unit, we have different exhibits. Particularly, we have like 16 interactive physics exhibits that explains physics phenomena, such as conversion of energy from one to the other. We have also resonance, exhibits that show resonance effect, exhibits that show diffraction, and we do have also exhibits that describes, for example, buoyancy, effect of pressure, and so on and so forth. Altogether, we have like 16 of them, and these are home built. The manual is the recipe was prepared by staff from physics department of Addis Ababa University, and locally these were constructed, and they explain different physics phenomena such as Pythagoras theorem and many more. We do have also a Children's Science Center where children come and interact. And in this center, we have about 48 different exhibits, which describes different phenomena like optics, effect of mirrors, and effect of, for example, magnetism, specific heat, and many more. And under this Children's Science Center, we have something like 48 different types of exhibits. All of them explains some of the basic principles of physics, and in some of the cases, some of the basic principles of mathematics and engineering. And children around the city come and enjoy and experience, hand-on by simply looking at these exhibits. So these are a few examples. For example, what you see in this slide is a plasma production, and the other one where you see conversion of potential energy to electrical energy, and so on. And mathematical concepts are also can easily be explained with the help of these items. And we have something like 48 of them. So these are some of the partial view of exhibits at the Child Center. In addition to the interactive exhibits that I indicated, 6 of them, we do have also a STEM Center. At the STEM Center, what we do is during the summer, we invite students, particularly pre-university students from catchment area. Because of our capacity, we don't take large number, but each year we have something like 45 to 50 students, and they will study, they will be taught coding and also electronics, theoretical concepts for about 2 months. Then after, they will develop a project where they produce a prototype. And once they are through with the prototypes, they will compete between each other, and those who rank 1, 2, 3 will compete also nationally. There are about 60 such centers, throughout the nation, and once in a year, at a time where there is a UN Science Day around November, they will compete with their prototype that they produced after the 3 months training. So these are a few examples, for example. And here, these are 3 examples which we have. Stair climbing balanced wheelchair, which was constructed by high school students, trained only 3 months. Density-based traffic signal system, multiple platform security system. And these are high school students, and this helps them to inspire, so that when they join university, they clearly know which department to join. For example, the first one, the stair climbing balance wheelchair, was constructed by one high school student who joined university, and now she is studying computer science, And because of the idea that she garnered when she was here, she was able to even produce, prototypes at the university level, and she even had a chance to visit, some exhibits in Switzerland and in China. We are also planning to have engineering, robotics, and environment and agricultural units. As a way forward, we want to have tailored curriculum to encourage STEM students. We want to co-organize a national STEM education program. We want also to develop standards and implementation of national science fairs. And we want also to conduct professional development programs for science and mathematical teachers. And we want also to have building the technical capacity of STEM centers in the region. In addition, we want to establish a Fab Lab. IAP had a call which we applied for, and we were one of the 5 STEM centers in Africa selected to get funding from IAP. We already had the first seed money. Our main target in that project is to establish a fabrication lab, a lab where we try to produce items which will be packed and distributed with minimum price to different high schools. This is an idea that we have and it's under making, and we already have CNC machine, which we already bought, and we have also laser cutter and 3D printing for establishing this fabrication lab. These are some of the items that I already mentioned. Regarding the professional development training for science and mathematical teachers, as we are a national academy, we are thinking to work on how to contribute in STEM education nationally to schools throughout the nation. We want also to have practical training programs for professionals in selected areas where needs are highest. And these are also areas where we look also for collaboration. And we want also to establish capacities of STEM center using our background that we had and experience that we had so far. That's all briefly. Thank you very much.
Yeah, thank you so much. Lots of questions in the chat. We'll select 1 or 2 of them, and then we'll go to a broader Q&A where people can raise their hands using the function at the bottom of the screen under React. But let's take 2 questions for you. The first one is from Mohammed Hassan. Are there any interactive exhibits that demonstrate how science can be instrumental in addressing specific issues related to the Sustainable Development Goals, the SDGs?
All what we have, all the exhibits that we have, one way or another, contributes to the Sustainable Development Goal. It might not be direct, but indirectly, that's what I could say. I can mention specifics, but for example, if the students are strong in the basic sciences, and if they are strong on renewable energy, we have already a solar panel that we have where students have practical things, which contributes for sure for the environmental target that is there in the Sustainable Development Goal. So as I said, one or another, the science exhibits, the STEM centers for sure will contribute for the Sustainable Goal.
And that ecosystem of learning, as someone who works in formal education, K through 12 or primary and secondary school, making certain that students have opportunities to learn in all of these places in their community, including these science centers, is crucial. Peter, did you want to add anything to that question, given your expertise?
No, I think we can move on. I think.
Okay.
Thank you.
All right. So one last question for you, Tekatel. What role do you think science centers, and you can summarize this before we turn it over to broader Q&A. What role do you think science centers and science museums should play in building the public's trust and understanding in science?
I think that science centers and science museums for sure will build trust by the society. The museums that we have, the centers that we have, are not open only for students. It's also open for the public. There are areas where the public sees science as something that's not graspable, but when these people come, even the elderly people, when they come with their parents, with their students, they are highly excited, and they see how science explains some of the basic phenomena in the simplest form. And therefore, the science centers and the science museums contributes not only for inspiring the children, rather inspires also the family as a whole, the public as a whole. Therefore, it is important. For example, in Ethiopia, we have now big science museum under construction by the government. And the reason why the government have this huge investment is not only for children, but also to popularize science for the public. By the way, this is also one of the contribution of the academy, the Ethiopian Academy. The idea emanated from the academy. And that is for public, not for children. Therefore, for sure, it will contribute for the public.
Yeah. Promoting lifelong learning in science and trust.
Yes.
All right. So now what we'll do is open it up for questions. If you have a question that you'd like to ask of Bruce or any of the three panelists, please don't hesitate to just either unmute and ask your question, or better off, if you can go to the React button at the bottom and raise your hand, select the raise hand function. That'll put you at the very top. And we will take your question. So Mohammed.
Thank you very much. I think there is an issue that is extremely important, and that is, in addition to education, I think we have to do something about gaining public trust in science. And that can be done. I mean, I mentioned what I asked earlier about how we can promote the issues related to poverty, to climate change, biodiversity loss, and so on, through science education, science museum, and so on. I think it's a very critical issue, and I'm very much intrigued by the Stanford University Poverty and Technology Lab, which was established in 2016, and it links with the Silicon Valley, and the students are undergraduate and postgraduate students from Stanford University, but they are exposed to certain issues that can help in the poverty issue. So it's things like that, I suppose, that IAP should start to think about. Issues that not only for students and inquiry-based science education, which is absolutely important, but issues that can actually generate this trust in science, because they see, the population see that science is really useful to address their own problems. So there may be many ideas related to this, but I think maybe this is an issue that should be dealt with later on with IAP.
Yeah, thank you. Does anybody want to address that statement or respond to that statement from Mohammed?
So
Bruce?
I just wanted to say I was a trustee of the California Academy of Sciences, a big science museum in San Francisco for 6 years, and I was totally frustrated because they only show the great things that science has discovered, which is a traditional thing that museums do. But I could never get them to try to create an exhibit which demonstrates how science creates knowledge. the kind of thing that I was talking about in my talk is not generally shown in science museums. Is again, it's because everybody follows a tradition. Museums, traditions that show how wonderful things are known because of science, and they haven't really come to grips, most of them, with the importance of getting the adults in the museum to understand how do we know that vaccines are safe, for example. There's never an exhibit like that. Or how does science know, things about climate change? It's just not been a focus. Just like in teaching in science schools, it's always been about science facts. And trying to get science education redefined as science is inquiry. This is what IAP Miguel's father started IAP, 25 years ago. It's getting people to change their view of what a museum is or what science education is hard work and it's slow going, but we need to do it.
Agreed. And coming from a massive institution called the Smithsonian with 21 museums, as well as a Science Education Center, completely agree that knowing whether or not we're producing knowledge or people are understanding science and developing their scientific expertise, not easy to do when people walk in your museum and then Verena.
Thank you so much for the wonderful presentations. I come from the National Museums in Berlin, and I was wondering, as we talked a lot about humanity and the role that science education should play, that we should focus also on the humanities. This is something that is a little bit missing in IAP, I understand, and I was wondering what your take would be. But I think the beautiful example of our Malaysian colleague showed how history should be and can be involved in order to promote further science education. So I was wondering what the other colleagues who would think about this to bring in more humanities in the arts, for example, or in other fields where museums can play a major role. I mean, it's not only the science museums, but museums that are research based, of course. Thank you.
Any of the panelists or Bruce? Well, I will just say that in collaboration, Peter mentioned this at the beginning of the talk, but the Smithsonian Science Education Center and the InterAcademy Partnership are collaborating to build courses for youth and educators focused on the socio-scientific issues that exist. And it is truly an integration of, Verena, history, art, culture, science. That's inherent in the Smithsonian Institution, and I believe in so many of the amazing people that we've been introduced to through IAP. And we highlight for young people all the different backgrounds that exist in the field that contribute to any of these topics that align with the SDGs, whether it's biodiversity loss or climate action, or it's around biotechnology. And so I completely agree with you that this idea of the humanities and the role that they play in helping people feel as if science is accessible to them. And that's really important for us as educators. Does anybody else want to contribute?
Yes, our academy, the Ethiopian Science Academy, the name says science, but we have 6 working groups. We have the agriculture, the health, engineering and technology, social science and humanities, and art and culture. And by the way, I mentioned today I presented only the science centers that we have. We have a creative arts center. It's called Blatte Ngeta Hiroi Creative Arts Center, where we focus on music, art, culture, book review, and many more. We have the combination of that, and we want to expand also that. So as we have a science center in one hand, a children's center, we do have also a creative arts center. That's where we focus on music, even on social science issues. So we combine all together. Our science academy is a combination of 6 different working groups.
Thank you so much.
just to say, I would love to see history museums, for example, try to teach people how we know what's true and what's not true. I mean, there's truth in history and there's, fake history. So I think that's a wonderful challenge for many different fields, is how do we distinguish truth from falsehood?
Yeah, thank you so much, Bruce. Now we've just got a couple minutes left to the originally scheduled program. Moses, maybe we could take one more question, and then did you want to open it up if people wanted to stay? How would you like to proceed?
Yes, I think we can take 1 or 2 questions. If there's any more questions, sometimes we allow 5 extra minutes, but if there's no engagement, we can just complete.
Okay. Dorothy and then Maria.
Hi, thank you. This is absolutely wonderful. I feel like I've come home. I'm a scientist and an educator by trade, and 7 years ago I left my lecturing post to start my science education company. And I'm very, very passionate about this thing that science is for everyone and it's everywhere. And I've started an online science club. It's for adults, for grown-ups, because one of the other things I do is that I run primary, so elementary school, after school science clubs. But I'm finding that a lot of the parents are just scared of science or don't, one of the parents said something a while ago that's back to seeding me, and this switched me on to trying to help adults. Because I find that there's a lot of adults that have just missed out on science, or they did it and they're in a completely different career now and they miss science. So I'm starting to, I want to build a community of interested adults like that, but also to really, there's so many things about today, especially about tackling misinformation and so on. So I really just wanted to say thanks, but my question is how can we, kind of follows on to the last point about how science is done, are there any good resources out there for helping people learn about the scientific method? Because I talk about that a lot and I would love to, I think now it's so important that we really help people understand that. This is all about scientific literacy and understanding and trust. So yeah, how do we teach people about how science is done? We mentioned museums, that might be difficult, but I would love to get a handle on that. So thanks for listening and thanks for the whole presentation.
Bruce, do you want to take that question? How do we teach people how science is done?
Dorothy, where are you located? What country?
I'm in Glasgow in Scotland.
Oh, okay, good. I think this is great. I mean, this kind of connection is important for us to, I've never been on social media, so I'm hopeless. Nobody knows I exist anymore. But I think we need to experiment. We're all scientists. We need experiments on how to reach not only children. I think that's easier because we have a school, but how do we reach adults in a way that actually helps them understand? As we all know, it's much harder to change an adult once they got an opinion about climate change or whatever. It just sticks. They're not as flexible and amenable to change. But I'd love to try to work with you if you could create an experimental way of trying to use these adults using various kinds of materials. We're just struggling now with trying to figure out what are the different approaches that could be used to try to get children, but it also applies to the adults. So if you have them accessible, what's the most effective way of trying to get them to really understand how science works? And our website collected things that other people have done, but we need new ideas. To what extent, for example, can we use science history to try to make them understand, how science works and appreciate that the scientific community creates reliable knowledge. It's not just individual scientists. My academy produced, when I was president in the 1990s, 18 pamphlets called beyond discovery, the path from research to human benefit, and each one traced back something like, for example, the GPS system. Where did that come from? Well, it started, 30 years earlier with physicists inventing atomic clocks that keep track to a billionth of a second. At that time, nobody had any idea that would even have any use. But then how it was combined over time to produce something that really changed our lives and lets us drive our cars without maps and all kinds of other things. And then we did one on the cure for childhood leukemia, which is really a very accessible kind of a history. But, how could we take materials like that and make them into teaching materials? Or, how can we actually get, anybody to do what we know makes a difference in education, not only tell them something, but they have to struggle with it themselves and produce something. So how do we produce an inquiry kind of a curriculum that leads to real understanding of how science works? And I think that's a real puzzle for all of us. The website we created tried to collect things that we could find that were produced in the past, but I don't think in the past we actually recognized how powerful misinformation could be. We didn't have social media, we didn't have Fox News, we didn't have all those things, and now we need a new focus that's trying to deal with those issues. And the people in the past were dealing them with the nature of science in a different context, but their material is useful, but it's not enough, I don't think. We need to develop new stuff.
Yeah, and I think also with, so you mentioned social media and the fact that all these billionaires are executing a takeover of social media, that's really worrying. So that's maybe something to think about as well, this kind of communication.
Yeah.
And I just want to make note, I think Rania Moses, did she drop off?
Yes, she had to drop off
Okay.
another meeting.
Yeah, I'm so sorry. I wanted to make certain that she had a chance to introduce herself, but I think that she put some information in the chat about the InterAcademy Partnership and her role at the U.S. Academy. Okay. Moses, do you want to take one other question or give the speakers one last round to add something, their final thoughts? What would you prefer?
Yeah, I think we can give the speakers one last round to share their final thoughts in about 30 seconds or a minute, and then we conclude.
And then Maria, if you want to stay on after, we can take your question. So Miguel, do you want to get us started? Any last thoughts from you? Especially given what Bruce and Dorothy's question asked about adult learning and how we address it, given your students are all.
Yes. I mean, one option, I guess, is to give up hope on adults, but I think everyone is thinking that we have to act quickly and convince people that science is useful for many things that are not related to science itself. As Bruce mentioned, things like democracy are at peril with an approach that is not based on evidence. So I think that the proposals that have been made here are useful, and I think maybe the museums are the way to go. The approach with the teachers, I think, is very complicated because teachers are under a lot of pressure to make sure they comply with their curricula and so on, and they need to kind of address those things first. They have little time for training and things, and we always get the people who are really interested, but we're not reaching everyone. So I think a combination of education at the school levels, but also with the museums, the academies of science should take a much bigger role in promoting science among the governments and trying to get them to talk about these issues. And we need a bigger presence in the way that things are moving along now. Not only social media, but artificial intelligence, for example, could be a great tool to help us in this sense. Artificial intelligence itself was created by science, and it's something that everybody's going to be using in the short term. So I think that we have some ideas that can be taken, that can be put into practice, but it's difficult. You need funding. You need a lot of people working on this, and I think that the scientific community should dedicate a good part of its time to this, or else we're in grave danger of ceasing to exist.
Absolutely. And Moses, I think you have your next topic for your next webinar, artificial intelligence in science education and promoting trust in science. Sharifa, do you want to add anything?
Sharif, I think you're muted.
Sharifa, can you unmute? Thank you.
Thank you. Yes, since I talked about the interdisciplinary approach to teaching science, I think it is important for children to understand that science has history. And through incorporation of history, it makes the teaching more attractive. And I think it's a new dimension, or not new, it's an added dimension to the teaching of science instead of just teaching the facts. And the courses that we have done for teachers prove to show that they have never thought that history could be that interesting and could relate to science. And then back to the role of how to make science how to make science accessible to people. I think I agree that the science museums play a big role. And also, I think we need to impress upon teachers that the science discipline is very useful in terms, because it deals with accuracy, it deals with precision, and it deals with evidence-based conclusion. And of course, also in analytical skills. And these are very important skills which children need to have. And in fact, if students undergo through an effective science education, they will make better lawyers, not just good scientists, but also better lawyers, because of the disciplines that science promotes in the teaching.
Absolutely.
So
reasoning from evidence, right?
Yeah.
And then is there, Tekatel, do you want to add any final comments before we close?
I want to just mention that we need also to focus on women in STEM, which we are thinking in our academy, to have women STEM for women, STEM in science, women mentorship, and so on. So that's one of the areas that we are focusing, because as you go higher in the ladder, I don't know, in our case, at higher education and research institutions, we have only few women. At lower level, it's now around 50-50, but particularly in the science area, we have few of them. And that led us to work on women in science, women mentorship, and women in STEM. And this is one of the areas that we are working, and we need to focus also at that line. This is one point that I want to indicate, because it didn't came out in our today's discussion. Thank you.
Completely agree. And there certainly have been studies that show women are much more communal. And as a result, their connection to communities and to people potentially could help address this idea of building trust in the public around science. Bruce, Peter, Moses, I'll turn it over to you for any final remarks before we do wrap up. And then, of course, we'll stay on for Maria. Bruce, any final remarks from you?
Well, I talked enough. I think this has been great for making new connections. Anybody who wants to get in touch with me, you could Google me and find my email. I'd love to collaborate. we need everybody to work together on this huge issue.
Well said. Peter?
Well, just on that point, I noticed, Dorothy, you're in Glasgow, and I'm a Glasgow graduate. I've already noticed in the chat, I sent you my email and offered to connect you directly with Bruce, but connect with IAP, of course, we'd be happy to link. As Carol mentioned, that our colleague, IAP colleague Rania had to leave. She was due to give some sort of closing remarks, but I've got here in front of me what she put in the chat, so maybe I'll go through this a little bit. Thanks, of course, to all today's speakers. I think it's been a wonderful session, and part of that has also been the contributions from you, the participants. The questions we've had have been really engaging and stimulating. I think it's fair to say that this has been the most participation we've had in one of our IAP webinars so far, so you've helped us set the bar pretty high. Of course, science education is more important now than ever. I think we all understand that, and especially at this time when trust in science is being questioned more than ever before. We must ensure that students, educators, and the broader public, adults, juniors, everybody, have access to a high-quality, evidence-based science education. And this is, we understand, or we believe that this is critical to fostering informed decision-making, which can help strengthen societies and address global challenges like the SDGs, like climate change, and so on. So we're very pleased for IAP to be taking an active role in this space to bring you all together, other experts, institutions, and networks, to hopefully drive meaningful progress. Collaborative efforts like this are essential to equipping the next generation with the skills and knowledge they need to navigate an increasingly complex world. Okay, thank you all for your attention.